So we start in about 1 minute. Melbs is the co-founder and president of Electroninks. They've been one of our supporters for 2 years now, so thank you for that. And they do some really interesting metal organic sort of particle-free inks. I mean, you will explain, but I think you do kind of a family of inks, so silver and others. And they have some really interesting applications. So I think it's going to be an interesting presentation. So we just give it a few more seconds before you can start, so that the audience comes back to the room.
No worries.
All right, so now let's start. I think we're all set. The slides are on and the stage is yours. Good luck.
All right, thank you, Kasha. Good to be here. Thank you for the invite here, and really happy to be talking with everybody. My name is Melbs LeMieux, president at Electroninks, and today, as Kasha just kind of previewed, we're going to be talking about our portfolio of metal complex inks, specifically applied to additive manufacturing and advanced packaging, and a little bit of PCB work thrown in at the end here. So quick agenda, again, overview of our technology, the product portfolio, some of the use cases in advanced packaging with focusing on all printing methods. And then really, as an ink vendor, we have to really relay the value propositions and features to customers, impacts on both technology and cost. I'll review those quickly. And then, as I mentioned, a quick blurb on our PCB work with our CircuitJet rapid prototyping ecosystem. Okay, so what's the thesis of what we're doing here? We all know there's plenty of different varieties of nanoparticle inks on the market today. Most of those are sort of the general nanoparticle materials where you take an inorganic phase particle, mix it with binders, surfactants, and you have a dispersion of a conductive ink that can be screen printed or digitally printed. One of the issues with digitally printing nanoparticle inks is you have limitations in reliability due to the nozzle clogging and other issues, recirculation. There's several issues with that. What we wanted to do to provide, ultimate reliability to our customers, as well as performance that actually can get close to PVD type metallization, is look at what's done in semiconductor chemistry. And so we look to the sort of the precursors and the ligands that are used in CVD ALD precursors. And translate those into conductive inks. So at our core, I would say Electroninks really is a precursor chemistry company. And we develop precursors, which is sort of 10% of the challenge, 100% of the IP, 10% of the challenge. And then we take those precursors and formulate those into inks that can be printed with different printing technologies. And one thing here is, we have to differentiate between printing, for a few hours versus printing for mass production. That's been the engineering challenge that we've tried to overcome in the past 3 to 4 years is, for things like inkjet, aerosol jet, making sure these can print for days to weeks at a time in print heads without issue. So some of the features of nanoparticles and MOD inks, and some of you may have seen this slide before in a few of our presentations. But first and foremost, the film purity is sort of self-limiting to get high high percentage of the element. So whether it's silver or we have some other materials, if we do the reduction right, we get the stoichiometric balance of the formulation, cure it appropriately. We should have a very high level of the metal. So 3 to 4.9 metal content is pretty typical. Skipping on down, I don't want to go through all these. I will say film reliability, that's something we try to hang our hat on. Our standard is MSL2 testing for the